Hello everyone, welcome to Nalanda EDvantage. In this video, we will learn about production of sound, propagation of sound and the sound waves. So let's quickly start. Whenever you are stuck in a traffic or you are listening to your favorite song or randomly when you're talking or someone is listening, what is the common thing that binds all these things? Well, the common thing here is the sound. So definitely we can say that sound is a form of energy which is made by vibrations. The vibrations, these are the rapid to and fro movements of an object. Now, how does a production of sound occurs? When an object vibrates, it causes the air particles around it to move. Not the particle moves, but generally the air around it displaces. These particle bumps into the particles which are closer to them, and then they continues until they run out of energy and then they dissipates. For example, the human voice, the way I'm talking and conveying my words towards you, it means it is produced due to the vibration of my vocal cords. Now see this activity which will prove that how does the vibrations are responsible for production of a sound. Now for this activity we need a tennis ball and a tuning fork. Tuning fork is a device easily available at in your labs. They consist of two tongs which can vibrate when pushed upon. So you strike these prongs of a tuning fork on a rubber pad and bring it near the ear. We can hear a sound. If a suspended tennis ball is touched with this vibrating prong, the ball is pushed away repeatedly. Okay, so this shows that the prong is vibrating and these objects which are vibrating, they produces the sound. So this is the tuning fork before striking. That means, and as soon as the tuning fork is struck, the ball is pushed away. Hence, it proves that the tuning fork is vibrating and is producing the sound. Now let's see here what is propagation of a sound and how does the sound moves. The sound produced, so in this example we have taken the tuning fork in the previous example, and there is the medium present through which the sound travels, and then there is the receiver. For the receiver we have taken the ear. Now let's see the propagation of sound. The sound propagates, it's produced by a vibrating object and it always travels through a medium towards a listener. In this form, the source here is the vibrating fork or the tuning fork, and the medium here is the air by which the sound is traveling. And this one here is the listener. When an object vibrates, the particle around the medium also vibrates. This particle is in contact with the vibrating object, is first displaced from its equilibrium position, and it then exerts force on an object closer to this, and this particle is displaced from its position of rest. So this particle exerts pressure on its nearby particle. After displacing it, the original particle comes back to the rest at its original position. Hence, this process repeats in a medium till the sound reaches the ear. So first of all, this vibrating fork will create the vibrations. These vibrations will move further away and away until unless it displaces the next particles. Ultimately, it reaches the receiver. This is how your propagation of sound is passed on, or is it happens. Do you know the fun fact that the geologists use their knowledge of how sound travels through rock to help them find the oil fields? Now let's see the propagation of sound through air in a much more detail. In this diagram, we have the tuning fork here, the similar tuning fork that we have been talking about, and as it vibrates, it creates the vibrations. Now, air is the most common medium, okay, through which the sound travels. Now, this in the first diagram, we can see the tuning fork is at a normal equilibrium position and the waves are created in a proper gaps, means the pressure is equally divided in the air. There is no high pressure or a low pressure. Now when a vibrating object moves forward, so it pushes and compresses the air in front of it. Okay, so it compresses the air in front of it. As a result of it, it creates a pressure of high zone. Okay, it creates a high pressure, which are known as compressions. Now these compressions moves away from the vibrating object. They will further move away. When the vibrating objects moves backward, it forms a region of low pressure. Okay, so what happens? The vibrating object, when it again moves backwards, okay, it again moves backwards. So ultimately, as the compression moves forward, the object, that means the pressure is moving forward, okay, but the object remains at its original position, as we have discussed in the previous slide. So it causes the low pressure area. Okay, this causes a low pressure region, which is known as rarefactions. It is a region of low pressure. Now as the object vibrates, it produces a constant compressions and rarefactions, which leads to the sound to propagate in the particular medium. I hope this is clear to you, as any sound which is traveling, it requires a medium. This medium can be solid, liquid or gas, although you need to remember that in the solids the sound travels the fastest, then the liquids and then the air. The sound does not travel in the vacuum at all. So sound requires medium to travel, and it travels back and forth in a regions of high regions and low regions, known as compressions and rarefactions. So this is the method by which propagation of sound occurs through air. In this diagram, the vibrating object is producing a series of compressions and rarefactions, as you can see. So you can see here in the first diagram, the compression regions were closer to the vibrating object. Now as soon as the compressions are moving forward and forward. Okay, so these are the regions of compressions and rarefactions. Now the region from one compression to the one rarefaction, right, you can see this. The region from one rarefaction to another rarefactions, or one compression to another compression, is known as the wavelength of a sound. Now these are the characteristics of a sound. There are various characteristics of a sound, particularly named as your wavelength, amplitude. Amplitude determines the loudness of the sound. Okay, time period and frequency. Now these time period and frequency are inversely proportional to each other. Frequency means how much the waves are produced in a particular time, how much the sound waves have been produced. And the last characteristic is the speed of the sound. Okay, now these sound waves, we humans, we have a hearing range. The hearing range of a sound wave is 20 Hz to 20 kilohertz. Below that, these are known as above that they are known as ultrasonic waves. Now the sound waves, the unit of a sound level is known as decibel. You must have heard of this during festivals. You can say that, or the noise levels, that amount of decibel unit is allowed. So here the unit of a sound is decibel. Now to prove an activity that a sound needs a medium to travel. Sound travels through solid, liquids and gases, and it does not travel in a vacuum. And you know the conditions where in the solid it moves the fastest, and thereby it decreases. Now for this activity we need a bell jar system, a vacuum pump and a clock or an alarm clock, anything that can produce a sound. In the first activity, when we put on the switch, electric switch, we can see that the clock, it rings and we can hear the sound away or in the air or in the atmosphere around us. As soon as we switch off the or we just vacuum all the air through the vacuum pump, and we switch on the electricity, and the clock is it is ticking up and alarm rings up, the sound is not moving ahead in the atmosphere or in the air around us. We cannot hear the sound. This proves that sound does not travel in a vacuum. It requires a medium. So on the basis of the characteristics that we have discussed so far for the sound, we can actually divide these waves into two. They are known as longitudinal waves and the transverse waves. Now the sound waves, they are longitudinal waves. That means these particles, the sound wave particles, they move back and forth parallel to the direction of propagation of disturbance. Okay, so such waves, they are known as longitudinal waves. For example, you can see here the slinky. This is the a toy which many children have. It's like a spring. They have individual coils, right? So when you put a dot towards it and you just stretch it out, you can see that the dot is moving in the regions of compressions and rarefactions. There is another kind of wave which is known as transverse waves, in which the wave particle oscillates up and down in a particular area. In the sound waves, they travel parallel, but in the transverse waves, they parallel perpendicular to the direction. So this was a bit about the sound and the sound waves. Now let's see the quiz quickly. In which medium will sound travels the fastest? Is it air, vacuum, water, steel, or sound travels fast same speed in all the mediums? So you know the correct answer here is steel. Sound travels fastest in the steel as it is a solid. Question number 2. What do we call the loud noise made by airplanes when they exceed the speed of sound? Is it Mach 1, sound boom, Mach sound, sound blast, or a sonic boom? So the correct answer here is sonic boom. That occurs when the speed, okay, when the speed of sound is exceeded by the frequency. Now let's see another one. Kilometer distance away from the point of explosion, but they are on two different points. One is underwater and one is on the land. Now you will have to tell me which will hear the sound earlier, whether X or the Y, or both will hear the sound at the same time, or Y will not hear the sound at all. Now because we have learned that the speed of sound is fastest in the water than the air, right? So over here we can see an X is underwater, so the X will hear the sound earlier. Question number 4. A vibrating body will always produce sound, may or may not produce sound if the amplitude of vibration is low, will produce sound depends upon its frequency, or none of these. So definitely the answer is C. The vibrating body will always produce sound that depends upon the frequency of the sound. Okay. So these are the few questions related to the topic. I hope it was fairly easy for you to understand. So definitely let's discuss the advantage edge. You need to work hard in silence and let the success make the noise. So thank you so much for watching this video. Do subscribe and share with your friends so that it will be helpful. Thank you once again.